Something left our solar system yesterday, and we have no idea what it was. For months, astronomers tracked an object they called 3I Atlas, the third interstellar visitor ever detected. It came from beyond our sun, sailed past Earth at 270 million kilometers, and is now disappearing back into the void. Case closed, right? Except the data that just came in doesn't make any sense at all. The object is too small to produce the activity we're seeing. It's wrapped in a dust cloud that sits at the exact optical thickness needed to hide something. And it's not following the path gravity says it should. It's steering, or being steered. Professor Loeb from Harvard just published calculations showing that this dust veil, this specific 10-micron particle shield, is either the most perfect cosmic coincidence we've ever seen, or it's engineered. NASA has issued warnings that the trajectory is now unpredictable, and the James Webb Space Telescope detected chemistry that doesn't match what millions of years in deep space should have done to this object. We're not here to tell you it's aliens. We're here to walk through the data that's making some of the world's top scientists ask questions they never thought they'd have to ask. Today we're diving into 3 pieces of evidence that don't fit: the impossible size, the perfect shield, and the trajectory that refuses to obey our models. This is not speculation. This is fresh analysis from NASA, Harvard, and the University of Canterbury. Make sure you're subscribed, because this story is far from over. Now, let's start with the number that changed everything. 3I Atlas, the interstellar enigma that held the world's gaze for months, is now receding into the dark. And if you think the story is over, you're mistaken. The most disturbing chapter has just begun. We thought we knew what it was. We thought we had a handle on its size, its composition, where it was going. But new data, analyzed in the wake of its closest approach on December 19th, has shattered those assumptions. The comet, if it even is a comet, isn't behaving according to our models. It's smaller than we dared to imagine, yet more active than physics suggests it should be. It's shedding a veil of dust that seems almost designed. And perhaps most unsettling of all, it's changing course again. Today we're not looking back at how it was discovered or the initial excitement. You know that story? Today we're diving into the raw, fresh data that just hit the desks of astronomers at NASA and Harvard. We're talking about the impossible size of the nucleus, the dust shield theory proposed by Loeb, and the unpredictable path that has NASA issuing new warnings. This is not just a rock tumbling through space. This is a mystery that deepens as it departs. Before we unravel these findings, make sure you're subscribed. The analysis of 3I Atlas is evolving daily. Now, let's look at what the numbers are telling us. Let's start with the biggest shock: the size. When 3I Atlas was first detected in July 2025, its brightness was anomalous. Too bright for its distance. Early estimates suggested a massive nucleus, perhaps 20 kilometers across. A giant. A world killer if it were on a collision course. But as it moved closer, that picture fell apart. Hubble observations initially constrained it to somewhere between 440 meters and 6 kilometers. That's a huge margin of error. But now, a new study from the University of Canterbury in New Zealand has narrowed it down with terrifying precision. By analyzing the non-gravitational acceleration, the way the comet's own outgassing acts like a thruster, pushing it off course, they calculated the mass required to be affected by that thrust. The verdict? The nucleus is likely between 820 and 500 meters in diameter. Let that sink in. We're talking about an object barely a kilometer wide. Yet this tiny object is generating a coma and tail that rivals comets 20 times its size. It's pumping out gas and dust at a rate that defies its surface area. If it were a standard dirty snowball, a nucleus this small, shedding mass this fast should be disintegrating. It should be falling apart. But 3I Atlas isn't. It remains coherent. It remains active. This discrepancy, a tiny engine driving a massive output, has led to a radical new theory. Professor Avi Loeb from Harvard just released an analysis that suggests we might not be seeing the nucleus at all. That three-eye atlas is hiding, literally. He analyzed the dust particles in the comet's anti-tail, that strange spike of dust pointing toward the sun that confused everyone earlier this month. His calculations show that these aren't your typical microscopic interstellar dust grains. Typical interstellar dust is less than a micron in size, like smoke. But the dust coming off Three-Eye Atlas? It's 10 times larger, around 10 microns. Why does this matter? Because particles of that size are incredibly efficient at scattering sunlight. Loeb calculated the density of this dust cloud and found something suspicious. The cloud is right on the borderline of being opaque, thick enough to block our view of the center, but just thin enough to let light scatter through. He calls it a veil of dust. Here's the problem. If this were a natural comet, for the dust to be this thick and block this much light, the nucleus would need to be at least 2 kilometers wide. But we know from the motion data that it's only about 1 kilometer. The math doesn't add up for a natural object. However, Loeb points out a chilling alternative. If you were building an artificial probe and you wanted to protect it from the sun's heat, or perhaps hide its true shape from prying eyes, a dust blanket of this specific density would be the perfect engineering solution. A shield made of 10-micron particles would effectively scatter sunlight, regulating temperature and obscuring the core. Is Three-Eye Atlas a natural object that just happens to have the perfect dust properties to hide its surface? Or is it a technological object deploying a screen? The implications of the dust spell are profound, but they pale in comparison to the immediate physical reality of the object's movement. Because Three-Eye Atlas isn't just hiding, it's swerving. NASA issued a new update warning that the comet's path has become unpredictable. We're not talking about the gravitational pull of planets, we're talking about internal forces. On December 27th, just yesterday, reports confirmed another sudden course change. The outgassing, the jets of gas pushing the comet, is shifting. Usually comets rotate and their jets spray in predictable patterns, like a lawn sprinkler. But Three-Eye Atlas is erratic. The thrust is changing direction, altering its velocity in ways our models are struggling to predict. It passed Earth safely at 188 astronomical units, about 270 million kilometers. We were never in danger. But this erratic behavior means we can't easily predict where it's going next. It's heading out toward the outer solar system, but its exact trajectory is now a cone of uncertainty rather than a precise line. Why is it twitching? Is the nucleus unstable? Is it tumbling? Or, if we entertain the artificial hypothesis, is it maneuvering? We also need to talk about the mass it's leaving behind. Loeb's calculations suggest that in the month after its closest approach to the sun, Three-Eye Atlas shed about 10 million kilograms of that specific 10-micron dust. That sounds like a lot, but it's only about 0.7% of the total gas it lost. This ratio, the amount of dust to gas, is similar to what we see in molecular clouds, the birthplaces of stars. This gives us a clue about its origin. If it is natural, Three-Eye Atlas might have been ejected from a stellar nursery, a region thick with these specific heavy dust grains. It could be a pristine sample from a baby solar system carrying the building blocks of planets from light years away, but that "if" hangs heavy in the air. So where do we stand? We have an object that's too small for its activity, hiding behind a curtain of heavy dust and steering itself, or being steered, off its predicted course. The scientific community is split. On one side, you have the naturalists, arguing that we're seeing a new class of superactive comets, perhaps rich in volatiles we've never seen before, explaining the massive outgassing from a small body. On the other side, you have the technologists, led by voices like Loeb, who look at the coincidences, the dust size, the optical depth of the cloud, the non-gravitational acceleration, and see signs of design. Let's talk about the anti-tail. In the world of astronomy, an anti-tail is usually a trick of the light. It happens when Earth crosses the orbital plane of a comet. From our perspective, The dust trail left behind appears to point toward the sun simply because of geometry, a perspective illusion, like railroad tracks converging in the distance. When 3i Atlas began displaying a spike pointing toward the sun in December, many astronomers dismissed it as exactly that, a geometric illusion. NASA reports initially leaned heavily on this explanation. Nothing to see here, just geometry. But there was a problem. The geometry didn't quite fit, and the physics was screaming something else. On December 19th, as 3i Atlas made its closest pass to Earth, the data became impossible to ignore. A prediction model known as the GCLM had forecasted this anti-tail weeks in advance, not as an illusion, but as a mechanical reality, and the images confirmed it. This wasn't just old dust drifting into view. This was a coherent structure, a jet. Professor Avi Loeb's analysis of this feature is where things get truly strange. For a tail to point toward the sun, the particles inside it have to be heavy. If they were small, like smoke, the pressure of sunlight, solar radiation pressure, would blow them back away from the sun, just like the main tail. To swim upstream against the flow of sunlight, the particles need mass. Loeb calculated that for this anti-tail to exist as observed, it must be made of particles around 10 microns in size. Why is 10 microns the magic number? Because it's the Goldilocks size. If they were smaller, 1 micron, the sun would blow them back. If they were larger, 100 microns, the gas coming off the comet wouldn't be strong enough to lift them off the surface in the first place. They have to be exactly in this narrow range to form the structure we see. So 3i Atlas isn't just shedding dust. It's shedding a very specific kind of dust, a monodispersed cloud of heavy grains. This leads us directly back to the shield theory. Loeb found another coincidence that's hard to ignore. When you calculate the density of this 10-micron dust cloud at the base of the jet, you get a value for optical depth that's almost exactly 1. In physics, an optical depth of 1 is a critical threshold. It means the cloud is just thick enough to become opaque. It blocks direct view of the surface. If this were a natural comet, there's no reason for the dust density to hang precisely at this value. It could be X0, 1 transparent, or 10 a thick wall, but it sits right at 1. Loeb speculates this coincidence could be a natural consequence of a self-regulating feedback loop, but it could also be a protective measure of artificial origin. Imagine a probe that needs to regulate its temperature, or a probe that wants to remain ambiguous. A dust shield with an optical depth of 1 is the perfect engineering solution. It hides the machinery. It diffuses the sunlight. It turns a hard metallic object into a fuzzy, natural-looking blob. Is 3i Atlas hiding behind a veil of its own making? The data says the veil is there. The question is, why? And then there's the heartbeat. Back in July 2025, shortly after discovery, astronomers noticed something rhythmic in the light coming from 3i Atlas. It wasn't a steady glow. It was pulsing. Variability in comets is normal. They rotate, and as they spin, different sides reflect more or less light. We call this a light curve. But the 3i Atlas signal was distinct. Some researchers described it as pulsed. If we're looking at a natural object, this likely indicates a rapid rotation or a tumbling motion. A small elongated object, like a cigar or a pancake, tumbling end over end, would create a rhythmic, flashing pattern. Given the new size estimates of just around 1 kilometer, a rapid tumble is physically possible. But there's an alternative interpretation that's been whispered in the corridors of the Galileo project. What if the jets themselves are pulsed? If the outgassing isn't a steady stream but a rhythmic venting, that would explain the light curve, and it would also explain the erratic changes in trajectory we discussed earlier. A pulsed jet is an engine. A steady vent is a leak. If 3i Atlas is pulsing its jets, it's effectively puffing its way through the solar system. This would create the non-gravitational acceleration that's messing up NASA's orbital predictions. It's not just drifting, it's thrusting. Let's combine these 3 data points. First, we have a specific heavy dust size of 10 microns that allows for a sunward pointing jet. Second, a dust density perfectly tuned to obscure the surface with an optical depth of exactly 1. And third, a rhythmic, pulsing light curve accompanied by erratic course changes. A natural explanation requires us to accept a superactive, tiny, tumbling comet that just happens to have a unique dust grain size and density. It's a lot of coincidences stacked on top of each other. The artificial explanation requires only one assumption: it's a probe. If it's a probe, the shield makes sense. The course corrections make sense. The pulsing makes sense. But there's one more piece of the puzzle that's just come to light: the dust mass problem. Loeb calculated that to maintain this shield, 3I Atlas is burning through its mass at a rate of about 3 kilograms of dust per second. That's about 10 million kilograms of dust in a month. For a natural comet of this small size, that's an aggressive diet. It's shedding mass so fast that it raises the question of longevity. How long can it keep this up? If it's been traveling between stars for millions of years, why is it still active? Unless it only turned on recently. Did 3I Atlas wake up when it entered our solar system? Did the heat of the sun trigger a dormant system? Or did it detect us? The timing of the activity, starting just as it approached the orbit of Jupiter and intensifying as it neared Earth, is consistent with a solar-triggered event. But the nature of that activity remains the anomaly. Now let's turn our eyes to the chemistry, because if the movement is the how, the composition is the what. The James Webb Space Telescope trained its golden mirrors on 3I Atlas back in the autumn, and what it found was backwards. In a typical comet from our solar system, as it approaches the sun, water ice is usually the main driver of activity. It heats up, turns to gas, and creates the coma. But for 3I Atlas, Webb found an abundance of carbon dioxide, CO2. The data suggests that the initial outburst, the one that made it so bright so far out, was driven almost entirely by CO2. It was a carbon dioxide engine. Only later, as this gas rushed out, did it drag crystals of water ice with it. Why is this important? Because CO2 is highly volatile. It turns to gas at much lower temperatures than water. This explains why 3I Atlas was active so far from the sun, way out near the orbit of Jupiter. It didn't need to be warm to wake up. It just needed to be slightly less cold. But here's the catch. If this object has been traveling through interstellar space for millions of years, cosmic rays should have processed its surface. We expected a crust of organic gunk, dark and red. Instead, we see pristine, volatile, rich venting. It's as if the outer layer was stripped away, or as if the venting is coming from specific, protected nozzles. The natural theory says this is a chunk of a Pluto-like planet, rich in CO2 ice, that was shattered and thrown our way, a shard of a frozen world. The artificial theory asks, is CO2 the propellant? If you were designing a low-temperature thruster for deep space, carbon dioxide is a readily available resource in many planetary systems. It's a common fuel. And speaking of deep space, we have to talk about where it's going. Headlines have recently screamed that 3I Atlas is racing toward Jupiter. And while that sounds like a sci-fi plot, the orbital dynamics are genuinely intriguing. When 3I Atlas was discovered, it was in the vicinity of Jupiter's orbit. Now, as it leaves its modified trajectory, remember the one that's changing unpredictably is taking it back out into the dark. The interaction with Jupiter is key. Jupiter is the bully of the solar system. Its gravity usually chews up comets or flings them out. But 3I Atlas didn't get chewed up. It passed through the danger zone, performed its perihelion maneuver, and is now exiting. Some trajectory models suggest that its non-gravitational acceleration, that self-steering we discussed, might be correcting its path relative to the gas giant. Is it using Jupiter as a gravity assist to leave our system faster? Or was Jupiter the target of its scam? We don't know. But the fact that it's wiggling on its way out, fighting the smooth curve of gravity, keeps astronomers up at night. A rock falls. A bird flies. 3I Atlas is flying. Finally, we must address the silence. Throughout this entire encounter, radio telescopes like the Green Bank telescope and the arrays used by Breakthrough Listen have been listening. They've scanned 3i Atlas for narrow-band radio signals, the hallmark of technology. The result? Silence. No beeps. No prime numbers. No "Hello World." Skeptics use this as the ultimate proof of nature. If it were aliens, they'd call us. But would they? If 3i Atlas is a derelict probe, a piece of space junk from a dead civilization, it wouldn't be transmitting. If it's a covert surveillance drone hiding behind a dust shield, silence is its primary defense. You don't spy on a house by ringing the doorbell. Or perhaps it's simply autonomous, a machine that collects data and stores it, waiting to burst transmit only when it returns to its home network, thousands of years from now. The silence doesn't prove it's a rock, it just proves it's not talking to us. As 3i Atlas fades from view, becoming a dim speck in our telescopes, we're left with a dataset that defies easy explanation. We have a kilometer-wide object that acts like a giant. We have a dust tail that points the wrong way and is made of the wrong stuff. We have a shield that sits at the perfect optical depth. We have a trajectory that shifts as if guided by an invisible hand. Is it a dark comet, a new type of interstellar iceberg? Or is it, as Loeb suggests, a message in a bottle that we're just barely learning how to read? One thing is certain. The universe is far more crowded and far more mysterious than we thought. 3i Atlas was the third visitor. It won't be the last, and next time we need to be ready to catch it. What do you think? Is the dust shield theory the smoking gun for alien tech, or just a desperate attempt to explain a weird rock? Let me know in the comments below. And if you want to follow the ongoing research into 3i Atlas, don't forget to subscribe. We'll be tracking every new paper, every new revelation, and every piece of data available, so you don't have to. Stay safe out there, ladies and gentlemen.